Welcome all. Today we shall see the manufacturing process of bioethanol. Before learning in detail the production process of bioethanol, we shall first find it out the raw material that is required for the production of bioethanol, that is the biomass. What is the constituent, or what are the constituent that make up the biomass? It is necessary that we must understand why this raw material has been chosen, biomass, because it is in a general sense biomass. Biomass can be anything. You will find it out. So what exactly is a biomass, and what constituent that make up the biomass? So the constituent of biomass are cellulose, hemicellulose and lignin. This cellulose is a common form of carbon which is actually 60% by weight, or it is actually present 60% by weight in biomass. Cellulose is actually 60% by weight present in the biomass. It is made from 6 carbon sugar polysaccharide. The next one is the hemicellulose. It is also a common form of carbon and is present 20 to 30% by weight in biomass. It is also a polysaccharide and made from 5 to 6 carbon sugar. So here you can distinguish the cellulose from hemicellulose. Cellulose is made from 6 carbon sugar polysaccharide, while hemicellulose is made from 5 to 6 carbon sugar. When you hydrolyze this hemicellulose, it gets converted into simple sugar, and this sugar is rather difficult to get it converted to bioethanol. Okay, so this is what we can say. Hemicellulose is little or it retards to get it converted to bioethanol. So cellulose, as it is composed of 6 carbon sugar polysaccharides, it can be hydrolyzed, and the 6 carbon sugar that is formed can be fermented to get bioethanol. So we can say that here the biomass, which is composed of cellulose and hemicellulose, both can be used, or both may be get converted to ethanol. However, cellulose, which is 6 carbon sugar, easily get converted to bioethanol upon fermentation, while the hemicellulose, which is composed of, or which is a polysaccharide made from 5 to 6 carbon sugar. So when this is hydrolyzed, it forms 5 and 6 carbon sugar molecules or monosaccharides, and these monosaccharides are rather difficult to get it converted to ethanol. Of course, this 5 carbon sugar also get converted to ethanol, but the process is rather difficult, or else we have to use enzymes, specific enzymes, in order to convert this 5 carbon sugar into bioethanol. Lignin is the third component of the biomass. It is also a form of carbon, and it is a polysaccharide. It is composed of 10 to 20% by weight, or it make up to 10 to 20% by weight. It remains as a residue. Okay, this lignin remains as a residue after sugar formation, as well as after the biomass get converted to ethanol. This is used mostly for converting into some sort of heat. Okay, this lignin, of course, this is made from carbon, so it can be burnt. Okay, it can be burnt. So when it is burned, the heat is utilized to make steam, and this steam can be used for generating the electricity. Okay, the steam that can be used for generating the electricity, and this electricity can be used further for bioethanol production. Okay, bioethanol production. So we can say that lignin is a energy source. Okay, lignin is a energy source which is a part of biomass. So all these three constituents of biomass are useful: cellulose, hemicellulose, and lignin. Now we shall see the manufacturing process of bioethanol in detail. So first of all, what raw material is required for the manufacturing process of bioethanol? Raw material or feedstock. So the first raw material is the agricultural residue, which can be crops, leaves, or any stalks. Forestry waste, that is dead trees, branches. Then municipal solid waste like household garbages can be used as a raw material for the production of bioethanol. Most importantly, today energy crops are grown in the field. Okay, energy crops are grown in the field. It is maize. Okay, it is a maize. This is a energy crop mostly used for the production of bioethanol today. So what are the steps involved in the production of bioethanol? We have seen the raw material that is required for the production of bioethanol. Now what are the steps actually? The first one is, the first step that we have to follow is the biomass handling. So why it is to be handled? It is that the size of the biomass may be large, so it is rather difficult for us to handle, as we know that smaller sections or smaller part of any material can be when it is exposed, then it can produce a good result. Okay, and that is why it is necessary that this biomass need to be processed, or it must be chopped, or it must be cut down, or it must be made smaller in size, so that it could be easy for handling, as well as it would be convenient to say that whenever the size of any raw material becomes smaller, then in that case the surface area increases, and whenever the surface area increases, then whatever the process we are doing on it would be efficient. Okay, whatever the process, then when we are doing on such a smaller parts or smaller particles or smaller size what we can say material, then the process become efficient. The next process which we are carrying on it becomes efficient. Therefore the biomass need to be chopped or broken into smaller pieces. So here agricultural residue, if we are using as a raw material for the production of bioethanol, then it should be ground or into smaller pieces. And if it is a wood, okay, if it is a wood, then it should be cut down into smaller or particle size, uniform particle size, so that it becomes rather easy for us to handle such material. Now the next step is the biomass treatment. Okay, biomass treatment. When you look at this flow chart, so this is the wood as a raw material, or this is the biomass as a raw material. This is first treated to make into smaller pieces. Okay, as for our convenience we make it into smaller pieces, because for any process it should be of smaller size so that we can handle it properly. Moreover, the surface area increases, and whenever the surface area increases, then the process become efficient. Whatever the process we are carrying on smaller particle size, then it would be open and it would be exposed, and so the process which we are carrying on these particles or smaller particle size material, the process become very, very efficient. So that is why the biomass first have to be handled, cut down into smaller pieces. The next one is the biomass treatment. So what raw material we have seen? Biomass. So biomass is composed of three different constituents: cellulose, hemicellulose, and lignin. So here the hemicellulose is the first constituent that must be treated. Okay, so hemicellulose is broken down into simplest sugar, that is 5 or carbon sugar. So for that, what we do, we carry out the acid hydrolysis process. Okay, dilute acid hydrolysis process, or it is hemicellulose is treated with dilute acid. Okay, dilute acid. So in the hydrolysis process, what happens? This complex sugar molecule, okay, complex hemicellulose sugar polysaccharide, okay, it's a polysaccharide, get broken down into simple sugar. Okay, this complex sugar molecule, that is a polysaccharide, is broken down into 5 or 6 carbon sugar molecule. So this is possible when hemicellulose is treated with dilute acid, that is the hydrolysis of hemicellulose gives us the 5 or 6 carbon sugar, or this polysaccharide, hemicellulose polysaccharide, is converted into 5 or 6 carbon sugar. Okay, 5 or 6 carbon sugar. This 5 carbon sugar is xylose or arabinose, and 6 carbon sugar is mannose or galactose. That means this hemicellulose is made from either 5 carbon sugar or 6 carbon sugar, or together. Okay, so hemicellulose is a very complex polysaccharide, and when it is hydrolyzed, what we get is a 5 carbon sugar xylose and arabinose, and 6 carbon sugar mannose and galactose. Okay, so this raw material is subjected to hydrolysis process. So hydrolysis of what? Hemicellulose. First we have done hydrolysis of hemicellulose. So it is done in presence of acid. So what we get is the simplest sugar molecule. Here in case of hemicellulose, it is 5 carbon sugar or 6 carbon sugar. Okay, similarly, some amount of cellulose is also get converted to glucose in this step. Okay, when we treat hemicellulose, when we hydrolyze hemicellulose in presence of acid, not only hemicellulose get hydrolyzed, but also cellulose also get converted into glucose molecule. Now next is enzyme production. It is very essential because enzymes are required. Okay, enzymes are required for the fermentation process or for the hydrolysis process. So cellulose enzyme, which is actually required for the cellulase enzyme. This is a cellulase enzyme. Okay, remember this, just you call this as a cellulase enzyme. So cellulase enzyme is required for the hydrolysis of cellulose. So this may be grown in the premises where hydrolysis or fermentation process of what we say sugar molecule is to be performed, or this can be purchased directly. Okay, cellulose enzyme can be grown there in the industrial premises, or it can be purchased directly. Okay, so cellulase is required for the hydrolysis of cellulose. So it is a step. Enzyme production is a step, or enzyme production is or enzyme purchase. Okay, you can purchase this directly from the vendors, or you can use, or you can grow this cellulose enzyme in the factory premises or in industry premises. So the next step is cellulose hydrolysis. So in this step, cellulose, okay, one of the constituent of biomass, cellulose. So don't confuse over here. Cellulose is a constituent of biomass, and cellulase, okay, cellulase is the enzyme which is of course required for the hydrolysis of cellulose fraction. Okay, cellulose fraction. So cellulose in presence of cellulase enzyme hydrolyze to obtain glucose, or cellulose is hydrolyzed in presence of cellulase enzyme to obtain the 6 carbon sugar glucose molecules. Okay, glucose, this is a monosaccharide. Since cellulose is a polysaccharide made from 6 carbon sugar, and that monosaccharide, that is the single unit, is called single unit is a monosaccharide, and it is a glucose. Okay, it is a glucose. It is a glucose molecule. So this cellular enzyme break down polysaccharide into simplest glucose molecule. Okay, sugar molecule. This process is also called as cellulose saccharification. That is, breaking down of this polysaccharide into simplest glucose molecule is called as saccharification process. Okay, so here the cellulose is broken down into simplest glucose molecule. So here we can say that this is a cellulose saccharification. Okay, cellulose saccharification. Now, so far what we have done, we have hydrolyzed hemicellulose and cellulose. And what is the result? 5 carbon sugar, 6 carbon sugar is the result of the hydrolysis of hemicellulose and cellulose. Now the simplest molecule we have got. Now we shall go for the fermentation process. Okay, fermentation process. The next is the fermentation process, glucose fermentation. So here the 6 carbon sugar, okay, 6 carbon sugar which is obtained by the hydrolysis of cellulose is then fermented. Okay, is then fermented in presence of certain bacteria. This is subjected, or this glucose molecule or glucose is subjected to fermentation process in presence of bacteria, and these bacteria convert this sugar molecule into ethanol and carbon dioxide. That means these bacteria are very specific, which consumes sugar and give out or excrete, I must say, excrete ethanol. Okay, excrete ethanol along with the carbon dioxide. So this is the reaction. Actually, this is the chemical reaction. We can write it over here. So this is a glucose molecule which is fermented in presence of certain bacteria, specific bacteria. They consume it. Actually, they consume it, or in other way, we can say that they eat this sugar molecule and excrete what? Ethanol along with the carbon dioxide. Now, pentose fermentation. So pentose is obtained after the hydrolysis of hemicellulose. It also get fermented and converted into what we say, ethanol. But the fermentation process of pentose require specific enzymes. Okay, specific enzyme. What that specific enzyme is? It's a Zymomonas mobilis. Okay, Zymomonas mobilis is the enzyme required. Okay, this is the Zymomonas mobilis enzyme is required for the fermentation of 5 carbon sugar. Okay, 5 carbon sugar, that is xylose. That is 5 carbon sugar is the prominent 5 carbon sugar of hemicellulose. Okay, so hemicellulose is mostly made from 5 carbon sugar xylose. Okay, that is a pentose sugar. Okay, pentose sugar, 5 carbon sugar, which is a part of hemicellulose, or hemicellulose is made from 5 carbon sugar, and therefore this 5 carbon sugar is subjected to fermentation process in presence of specific enzyme, what we call this as a Zymomonas mobilis. This enzyme is required, and this enzyme convert this xylose or ferment this xylose into ethanol. Okay, xylose into ethanol. So here you can see the raw material subjected to hydrolysis process. In general, suppose 5 carbon sugar, that is hemicellulose, is put to subjected to acid hydrolysis, while 6 carbon sugar, that is cellulose, that is that polysaccharide which is made from 6 carbon sugar, is subjected to cellulase hydrolysis, and finally what we get is the 5 or 6 carbon sugar, and this 5 and 6 carbon sugar are then put to fermentation process. So 6 carbon sugar fermentation is rather easy in presence of certain bacteria. They get fermented and produce bioethanol. Okay, produced bioethanol. However, for fermentation of 5 carbon sugar, that is xylose, what we require is the specific bacteria, that is Xynomonas mobilis. Okay, this bacteria is required, which also produce or xylose can be converted into bioethanol. Okay, bioethanol. So what is left after the bioethanol production? We get a bioethanol broth. Moreover, lignin is left. Okay, lignin is left. So here, after the production of ethanol, this ethanol may be present in a may be present as a dilute liquid. Okay, dilute liquid, or the concentration of ethanol. Okay, concentration of ethanol is very less, because most of the water may be present in a larger quantity, and therefore what we call this as a ethanol broth. Okay, ethanol broth, along with bacteria, enzymes that may be present along with the water, and what we call this as a ethanol broth. Ethanol broth. The fermentation product from glucose and pentose fermentation. Okay, the glucose fermentation and pentose fermentation gives what we call this as a ethanol broth, because this ethanol broth would carry bacteria, enzymes, okay, specific enzymes, as well as the concentration, the amount of water is more, and the ethanol quantity is less in that, and that is why we call this as a ethanol broth. So here, this ethanol must have to be separated from other compounds. It may be water, it may be unreacted glucose or remaining glucose or pentose. Moreover, the bacteria or enzymes that are involved in the fermentation process of 5 and 6 carbon sugar. So this need to be separated. Okay, this needs to be separated from the ethanol. And finally, what we do, we put this ethanol for the final distillation process. Okay, final distillation process. So through distillation process, what we could be able to remove is the water from the ethanol, or water and ethanol can be separated, and what we get, the ethanol in high concentration, up to 86 to 90% ethanol we can get. As we know that 100% ethanol can be obtained by one process, other process. Okay, so here by simplest distillation process, we cannot separate all of the water from the ethanol, since water and ethanol at 96% forms a azeotrope. Okay, azeotrope, and therefore absolute ethanol, what we call this as a 100% pure ethanol, can only be obtained by azeotropic distillation only. But here, by simplest distillation, as much as water can be separated from ethanol, and what we can get is the more concentration of ethanol, up to 80 to 85%. Okay, so this much concentration of ethanol can be obtained. What we call this as a ethanol recovery. Okay, from the ethanol broth, what we get is the high concentration of ethanol. Then what is left finally is the lignin. Okay, what is left finally is the lignin. So lignin is a source of energy. Lignin is a source of energy, and this is the byproduct left after the production of ethanol. Okay, this is the byproduct left after the production of ethanol or ethanol. Okay, so here this lignin can be utilized for the production of electricity, as this lignin has the ability to get it burned. So when it burns, it produces heat. That heat can be used, okay, for generating, for making the steam, or for generating the steam. Okay, so this steam can be used for running turbines. Okay, so when turbines run, it generates electricity. Okay, so the electricity generated by such a means, the electricity generated by such a means can be used for running the plant, which are producing the ethanol, or the plant meant for the production of ethanol. So electricity they may require. Okay, so that electricity can be used for running those plants which are producing the ethanol. Okay,